So now we have the mollusks, very quite diverse group, right? You have things that are like, especially oysters and clams in their shells. They don't look a whole lot like octopuses and squids. You know, these things have eyes very similar to our own eye, da 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 da. But they're all in the same group because they have these different kinds of traits that put them all in the same group. But again, mainly they have DNA similarities that put them all in the same group. One of the things they don't have that might be a characteristics that they use, they don't have a backbone, right? Only things in our phylum, Chordata, have a backbone. So if it says no backbone, then that eliminates the Chordata group. That might be one of the characteristics they give you. That in class, it's pretty cool. Here you have the kind that are, again, quite different in lots of ways. They don't have an exterior shell, but they have remnants of an interior shell, like these squid have a beak that they use to tear things up. So things I'll show in class. Now you have the one of the groups of worms that they did leave in. They left lots of groups of worms out actually, but this is the kind that's segmented. That's how they're different than the flatworms, the other kind of worms, right? That look like this again, that had a couple of eyes that were like cross-eyed. The platyhelminths are not segmented. These worms are segmented. So if they say worms that are segmented, that can only be this because there's no other group they gave you that had segmented worms. Platyhelminths also, again, don't have a digestive tract that's one way. These do have a digestive tract that's one way. These have a closed circulatory system. That's another difference that we didn't mention before. The mollusks have an open circulatory system. These things don't even really have a circulatory system. All these branchings of their digestive tract also act as a circulatory system. So um, these have some little things that are very much like kidneys in each one of their segments. This didn't make a list anywhere, so I don't think they'll throw that word in, but I just leech. So arthropods, this is the most diverse by far animal group. They got all kinds of different species, all kinds of different groups. Insects, crustaceans, those are the two most familiar groups to you. The group that spiders belong to is also pretty familiar to you. Arth means joint foot, literally jointed appendages would be the other word that commonly you have here. Jointed appendages would be a key characteristic of this group, hence the name, so that might be the thing they ask you about this. They have an exoskeleton. So do echinoderms, right? So it's not exclusive, but they have an exoskeleton. Um, and then jointed appendages, like I said, they also have body segments. So that makes them similar to the earthworm type, the annelids that we just looked at, but they wouldn't call these worms. So if they say it's not a worm, but it's segmented, then you're pointing in the direction of these guys. Okay, so the exoskeleton has to go for them to grow. I'll let you watch that in class. Got and we talked about that with circulatory systems. We talked about when we talked about kidneys and things. We said the analogous structures here are Malpighian tubules. They're tubes that bring nitrogenous waste out of their bodies, and then they have a set of tubes, a totally unique kind of gas exchange system that involve these tubes called tracheal tubes, right? And we'll review that again with some insect DVD. And here we go with, just here's tracheal tubes, which go all throughout the body here, bringing oxygen to and carbon dioxide away from every single kind of cell. Here you have these Malpighian tubules around their digestive tract, which is just absorbing nitrogenous waste and then sending them into their digestive tract, so they come out with their poop. Their urine and their poop are mixed out in the same thing. So there's kind of that. Here's again the cephalization idea. These again are bilaterally symmetrical. I'll say that again. So are the earthworms, by the way. I should have shown it there. Earthworms look like they might be radially symmetrical because they're kind of round bodies. But these things they have, the metanephridia, for instance, they have one on the right side, one on the left side in every single section of their body. So they are bilaterally symmetrical also. Um, we have this same kind of thing we saw with the crabs, the crustaceans. They have the blue crabs that I thrown in there. They have to get out of this exoskeleton. Insects do that as well. And then insects have this quite different forms as they grow up that we call metamorphosis, change in form, metamorphosis. And that might be a distinctive thing that they ask you about this phylum, because no other phylums have quite such distinctive stages of development to go from a thing that looks much more like a segmented worm, right, to a thing that is, got wings and things like that. So the echinoderms, the word literally means spiny skin. They have an exoskeleton, right? So that's kind of in common, but they are what's called pentaradial, and I forget if one of this is going to be on the next slide, so I'm going to do it. Many of these have more than 5 legs, but the most common pattern is 5 kind of sections. I don't want to call them legs, sections. And so if you divide them up, you can't really divide them into equal halves, right? Unless you divide like through here or through here. They're radial like in 5 different directions, hence the term pentaradial. Um, there it is. I don't know what else they would ask you. They have this system called a water vascular system inside. They have all these tubes. They also don't have a a one-way digestive system. They bring in food in the middle here. They circulate its nutrients around, and then they poop it right back out. So now we get to the phylum that you and I belong to, the phylum which not all of them have backbones. There's a small groups of chordates that don't have backbones, but what they do have is what gave this phylum its name. It's called a notochord. They don't go into any detail on this, so I'm going to skip it. Um, However, I'll put the name down here because they could throw that on the test and say you found an organism, it has a notochord. Well, right away, that puts them into this phylum. But then if they ask you more specifically, which class does this belong to, they're going to give you some other characteristics like it has feathers. So that puts it in the class which would be called aves. But notice here, for whatever reason, in the IB syllabus, they didn't use their specific class names all the time. Mammalia is their class name, Amphibia is their class name, Reptilia is their class name, but the fish's class name come in 2 classes, Osteichthyes, the bony fish, and Chondrichthyes, the cartilaginous fish like sharks. They didn't put those names in here. They also didn't put aves in here, which is the bird name. I'm not sure why. They stuck with the common name of birds and then fish. Okay, so about the evolution of jaws in fishes. All of the vertebrates evolved from fishes, right? Some fishes evolved into amphibians, some amphibians evolved into reptiles, and then some reptiles evolved into birds, and other kinds of reptiles evolved into mammals, and then we still have some reptiles around today, of course. So we'll look at this classic example of homologous structures, right? Are the gill slits of fishes and the gill arches they're called. And again, these develop in things like you and I that evolved from fishes, right? Way back when. This is your inner fish story. They evolved into things like our jaw, but also fish's jaws, but also things like your tracheal tubes, your vocal cords, and things like that. Your inner ear, remember those bones look like. Um, this is a big characteristic that evolved in these things. This is an egg with a covering around it that develops from a layer of what surrounds the embryo called an amnion um, that that amphibians don't have and fishes don't have. So they might, even though they don't mention this at all, they might use that as a defining characteristic of these, and these. But in the early reptilian ancestors, this was a key evolutionary development that caused them to be able to come out and live on land, so they could lay their eggs on land and they wouldn't dry out. And this is why if you're an amphibian, now we're going to make you an amphibian, you have to go back into the water to lay your eggs because your eggs don't have this waterproof covering. Just said, this is what I just said, kind of. Stay away from that road, I would say. Here's another thing maybe they'll throw in here, although again, they don't use these words, but um, there's some exceptions to this, but basically we have the temperature related idea of endotherms and exotherms, or ectotherms. Yeah, not ectotherms. They might bring this up in terms of mammals, endotherms, and birds, mammals and birds, and reptiles, usually ectotherms. Here's what it means again. Any kind of creature is going to generate heat. It generates heat because it does chemistry. And the second law says that some of the energy from that chemical reaction from those chemicals is going to be lost as useful work, right? Free energy. And that heat is going to heat up their body so that the chemistry can keep happening fast enough. So all organisms generate heat from their inside, endo. However, if you don't have much insulation coming from either a fat layer, mammals, a fur layer, other mammals, or feathers, birds, if you don't have much insulation to keep this heat inside, it's going to escape so quickly that you better rely on heat from your environment to keep warm enough. So that's the difference between an ectotherm and an endotherm. It's not that one generates heat from the inside and the other doesn't. It's basically that one can hold that heat better because it's evolved insulation. What that means is that in an evolutionary sense too, these things can live in colder environments than these things, reptiles. That's why you don't find crocodiles at the North Pole, but you do find some mammals. So we'll look at this reptile real fast. Snakes as a common example. That class. Here we have another funny, right? But this is a big evolutionary event. Those big volcanic eruptions, or excuse me, that combined with asteroid impacts that caused the extinction of so many kinds of things, including those things called dinosaurs, except those that we call from birds. So um, uh, characteristics of birds, they lay eggs, whereas mammals don't. At least most mammals. There's a group of mammals that do lay eggs. Spiny anteaters and or not them. Echidnas and platypuses. That's what I'm trying to think of. I don't know if maybe they would characteristics for flight. Obviously feathers. That would be the thing that says birds. That would make it an easy question. I can't think of much else they would ask you, to be honest. That's going to be a good little video that we see in class. Mammals, this would be very easy, right? Their class name comes from mammary glands, which are unique. Hair is unique. Again, endothermy possibly. Four-chambered heart, but birds also have that. And some reptiles also have that, actually. So that's not that really wouldn't be. It might be part of a list, but these mammary glands and hair, those are the things which distinguish mammals from those others. And I think we're done.